Good morning, my dear students. Today I am discussing about diode. Nothing means die means two, odd means electrode. Okay, it is a two-terminal device. It is made up of semiconductor materials. Nothing but two types. One is germanium, another one is silicon. Germanium means 0.3 volts, whereas silicon means 0.7 volts. Okay, diode means it is used to conduct current in one direction, and it offers a high resistance in other direction. This is the basic principle of a diode. Okay, next we go on for a PN junction diode. What is a PN junction diode? How it will be formed? It consists of two materials. First one is P type, another one is N type. P type means it is when trivalent element is added to a pure semiconductor, then it is known as an P-type semiconductor, P-type material. When N-type means when pentavalent element is added to a pure semiconductor, then it is known as N-type. Okay, P means anode and N means cathode. Okay, in P-type, it is having a negative immobile ions. Um, a majority carriers are holes and minority carriers are electrons. Same, whereas in N-type means it is positive immobile ions. Nothing but it's having majority carriers are electrons, whereas minority carriers are holes. Okay, now we discuss about what is meant by PN. Okay, I'm talking about main junction. Nothing but how PN junction will be formed. Being a supply voltage is positive and a negative. This means positive. P means P and N means N. Okay, when P type is connected to a positive terminal and N type is connected to a negative terminal of a battery. Okay, while applying the bias, it, the majority carriers and holes are used to move in N type, and minority carriers and electrons are moves into P type. Okay, they are used to form a junction, nothing but PN, nothing but depletion region. Once this region is formed, it cannot travel the charge carriers from one place to another. Okay, next one. In this, we can say that the depletion region is also known as space charge region. Nothing but it is a recombination of holes and electrons, right? Okay. Next, um, by simply connecting a diode, you have to place a resistor with the R. Again, giving a supply voltage, and the ammeter has been placed over here, and diode is being connected over here, and we are measuring voltage across diode, nothing but Vf, and current we are measuring nothing but If. Okay, and again giving a supply voltage. In this, we take voltage along x-axis, forward voltage, and current along y-axis. A graph is drawn. Nothing but a graph is obtained. From 0 to A, it does not obey Ohm's law. From A to B, it obeys Ohm's law. Nothing but a linear region. In this, the diode where cuts or allows the current is known as knee voltage, or it is also known as threshold voltage. Okay, okay. Nothing but this is an experiment. Another one is in a reverse bias, the current will be zero. For it offers high resistance in a PN junction diode. Okay, the width of the depletion region also increases. Okay, next in a reverse bias, same circuit has been redone by interchanging the simply the diode has been interchanged like that. Okay, we are measuring the voltage across diode is VR, and current across is known as IR. Resistor is simply interchanging the diode in the circuit. Okay, nothing will be changed. Okay, this is the reverse bias. How the for again you construct a, I mean PN junction diode fabrication with negative immobile ions or positive immobile ions. Already we shown that majority carriers are holes in P type, and minority electrons are more in N type. Majority carriers are minority carriers are holes. In this, minority carriers are electrons. Okay, if we given a negative bias to the circuit, Same charge means repel, opposite charge means attract. Nothing but when a negative terminal is connected to P type battery and N type is connected to positive, opposite charges means automatically it is used to opposite charges are attract with each other and same charges means repel. This is a basic concept. Okay, next we move on for GNR diode. Nothing but GNR diode can be worked in reverse bias condition. Nothing but nothing but it is used to give maximum current at its reverse bias. How it will be shown as by simply block diagram. Nothing but the diode has been taken as a jet terminal. Nothing but it is also P means anode terminal and N means cathode terminal. Okay, from anode to cathode the electrons will be moved and we are forming a junction. It's also this graph likely look like this. Again it the same graph for forward bias or reverse bias. Forward bias for PN junction as well as GNR are being same, whereas reverse bias means it is used to conduct more current, and that is known as IZ and minimum. Another one is IZ maximum, and GNR maximum current also can be achieved. This is known as breakdown region. Same circuit has been applied for GNR diode also. In this also a resistor has been taken, an ammeter has been placed. Like that a GNR diode has been connected. Okay, in this supply voltage has been given. Okay, again we are measuring a GNR voltage, nothing but VZ. Another one is IZ. Okay, same way this is a circuit similarly look like a GNR diode, nothing but PN junction. Another one is a tunnel diode. It is a thousand times greater than that of ordinary diode. Nothing but it's having a tunneling phenomena, so that it transfer the data from valency band to conduction band easily. By applying, it is also taking voltage along x-axis and current along y-axis. It is used to graph obtain a graph like this. From it having a peak voltage, another one is peak current. Nothing but from a 0 to a, it's having a high value. From whereas a to b it had work in a negative resistance region. Okay, this is the basic concept in a tunnel diode. Nothing but another one is a varactor diode. Varactor diode means again we are taking a PN junction diode of mobile charge carriers like negative or positive. Same circuit. Again we are considering a two plates across A and B. Nothing but in B we are taking a plate A as plate A. Another one is plate B. Both are separated by a distance nothing but D. Nothing but D. D means separation. We are considering like this, so that in varactor diode nothing but variable capacitor, so that it's having a capacitance known as CT, nothing but junction capacitance. Junction capacitance means it is proportional to nothing but area of cross section. It is proportional to 1 by D. Nothing but D is reverse voltage. It can be nothing but square root of reverse voltage. For CT is also written as a epsilon naught A by D. Okay, where epsilon naught is dielectric constant, A means area of cross section, D means nothing but the distance between two plates separated by D. Both are A and plates are separated by a capital small d. Okay, this is known as a varactor diode. Now move on for rectifiers. Rectifiers means it is nothing but we are having two rectifiers means it is used to convert AC to pulsating DC. Again, we are having two type of rectifiers, half wave. Another one is full wave rectifier. Again we are having bridge wave rectifier or okay, for move on for half a rectifier. In this we are using a simply a transformer. Nothing but transformer has some advantages like that you used to see. Nothing but we are placing a resistor RL. Okay, like that. Okay, you are supplying giving a 230 AC voltage, 50 Hz frequency. Okay, transformer means nothing but it is used to reduce the risk of electrical shocks. So that we are using transformer. It is used to depending on windings, secondary windings. It can be step up or step down. It can transformer efficiency can also be measured in terms of percentage. Nothing but output by input. Okay, now we move on the circuit. Okay, in this for positive cycle the diode will be conducted, as well as negative cycle the diode will not be conducted, so that d1 we are having a, so that we can obtain a graph like this. Okay, for a positive cycle the diode will be conductor, for negative cycle the diode will be zero, so that we are having a pulsating DC like that. Okay, this is in this for a half a rectifier we are measuring efficiency, that is also known as power of DC by power of AC. Nothing but in earlier we are having a sinusoidal equations, that is known as Im is equal to sine theta. There is a sine wave representation in every average value or RMS value. Again, it can be considered as PDC is equal to 1 by pi Im sine theta. By taking the abbreviation or integration, again it can be rewritten as PDC is equal to IDC into RL. Nothing but again equation has been rewritten, so that the efficiency will be, total efficiency will be 40%. In this we are also calculate the form factor. A form factor means average value by RMS value. It can also be written approximately 1.51. Next one we want to full wave rectifier. Full wave rectifier, again the circuit has been same, but both are separated by a center tap resistor RL. Okay, 0 A B C. I'm noting the notation. You can have like that. In positive cycle, what will be happen? In positive cycle, the upper diode will be conducted, that is D1, nothing but 0 0A B C. Whereas in negative cycle, the lower diode will be conducted, so that 0 E D A. This is have been happening. Again, the same efficiency is power of DC, nothing but power of AC. It can be up to 80%. Okay, and the form factor also it can be 1.11. In this entire half a rectifier or full wave rectifier, we can have a ripple factor also. That is in terms of IRMS by IDC. It can be also measured in half and full wave rectifier. Okay, again in bridge wave rectifier also, again the same transformer has been taken, but we are connecting four diodes like this. Both are separated by resistor RL. Okay, again in this positive cycle diode D1 D3 will be conducted, and the negative cycle D2 D4 will be conducted. Okay, same procedure will be happened. We are getting in a pulsating DC like this. In positive cycle D1 D3 conducted, in negative cycle D2 D4 conducted. How will be the pulsating DC is converted into direct DC by using a filter circuit. Nothing but filter means nothing but it is a frequency selector. Frequency selector means you can select the your frequency. Nothing but filters are of two types: active filters. Another one is passive filters. Passive filters means RL, RC, whereas active filter means you can use off amp, nothing but IC integrated circuit. Okay, how will be the filters means nothing but a low pass filter, nothing but it is used to allow low frequency as well as it reject high frequency. Same as in high pass filter, it is used to allow high frequency and reject low frequency. This is happens in filters. Okay, now you simply take in a R, again you connected a C. Okay, applying a AC signal. Okay, RC at critical frequency. We can write it as R is equal to XC. XC already you know, reactance of capacitor. It can be written as 1 by omega C. 1 by omega means 2 pi F, 2 pi FC. Again, again F is equal to 1 by 2 pi RC. This is the critical frequency calculation. How the critical frequency can be calculated as, if frequency is taken along x-axis and the gain is taken along y-axis, we can obtain a following graph like this. It is the maximum gain, AB maximum. After that, you can have a frequency known as minus 3 dB. Nothing but this is known as critical frequency. Critical frequency calculated. Critical frequency and calculated, so that we can calculate our frequency. You can achieve or not. Okay, same. Instead of the circuit is connected with an diode, it is an active filter. Okay. Um, how the critical frequency in terms of it can be written as in terms of power relation as well as a voltage relation also. Nothing but in terms of power as well as in terms of voltage relation. It is known as critical frequency. And then nothing but they can be obtained as a minus 3 dB cutoff frequency. This can be obtained from voltage divider rule for R and C. Okay, this can be obtained from transformer coupling circuits, octave, like decade, depending on their board plots. Okay, board plots we are getting the critical frequency. Okay, so that we can calculate the low pass filter, high pass filter, or band pass filter. Thank you.